Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about orthographic projections of the solids. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have been provided with an isometric 3D projection of an engineering object into which the front view face, the top view face and the left hand side view face of the solid, they have been combined into a single 3D isometric projection. Now using the constructional details available with us through this 3D isometric projection, we are required to obtain the front view orthographic projections, the top view orthographic projections and the left hand side view orthographic projections of this engineering object. In order to obtain the orthographic projections of the solid, we are required to obtain the dimensions of the front view face, the top view face and the left hand side view face of the solid. Now as we are going to look at the solid from the front view orientation, so we observe that the width of the solid, it is equal to 50 millimeter, that is 40 millimeter plus 10 millimeter, while the height of the solid has not been provided to us directly. So here we know that here we have got 20 millimeter height corresponding to the square vertical block which is lying at the rear side of the solid. Now as we look at the constructional details of the solid, so we observe that the height of this element, it is equal to 15 millimeter, while the height which is available with us corresponding to this element, it is equal to 10 millimeter. So the height of this horizontal web, it will be equal to 5 millimeter. So now we will see that this height of 5 millimeter plus this height of 20 millimeter will provide us with the total height of the solid as 25 millimeter over here. So therefore the dimensions of the front face of the solid will be measuring 50 millimeter width of the solid and 25 millimeter height of the solid over here. Similarly, when we are going to look at the solid from the top view orientation, then we observe that the width of the solid, it is equal to 50 millimeter, while the depth of the solid, it happens to be equal to 40 millimeter. So therefore the dimensions of the top view face, it will be measuring 50 millimeter by 40 millimeter. Now when we observe the solid from the left hand side view orientation, then we evaluate that the depth of the solid, it is equal to 40 millimeter, while the height of the solid, it is equal to 25 millimeter. So we observe that the dimensions of the side view face will be measuring 40 millimeter by 25 millimeter. Now we will be proceeding to evaluate the orthographic projections of the solid. Now in order to obtain the orthographic projections of the solid, we have drawn the XY reference line, X1, Y1 reference line and a transfer line originating from the intersection of XY reference line and the X1, Y1 reference line. And this transfer line, it is inclined at an angle of 45 degree with respect to the XY reference line. And this transfer line we are going to use in order to transfer the distances alongside the depth of the solid from the top view projections into the left hand side view projections over here. So now since we are going to evaluate the orthographic projections of the solid into the first angle projection method, so we are going to obtain the front view projections of the solid above the XY reference line. We will be obtaining the top view orthographic projections of the solid below the XY reference line, and the left hand side view orthographic projections of the solid will be obtained on the right hand side of the front view projections above the XY reference line. Now let us obtain the front view face of the solid into the orthographic projections. So we know that the dimensions of the front view face, they are measuring 50 millimeter width of the solid and 25 millimeter height of the solid. Now here we have drawn two vertical projector lines which are separated by the distance equal to 50 millimeter, which happens to be equal to width of the solid over here. And these two vertical projector lines, we have appropriately extended them into the top view projections as well, because into the top view projections also we are going to require width of the solid equal to 50 millimeter. And now we also know that this solid, it is having height is equal to 25 millimeter. So now we have to draw a horizontal projector line at a distance of 25 millimeter above the XY reference line, and this horizontal projector line we have once again appropriately extended it into the left hand side view projections over here, because into the left hand side view projections we are going to again require height of the solid equal to 25 millimeter. So here we have been able to obtain the front view face of this object measuring 50 millimeter width and 25 millimeter height over here. Now let us obtain the top view face of the solid. We know that the top view face of the solid is having dimensions 50 millimeter width and 40 millimeter depth of the solid. So this 50 millimeter width we have already obtained by extending two vertical projector lines from the front view projections. Now we have drawn two horizontal projector lines over here into the top view projection area, which are separated by a distance of 40 millimeter, which happens to be depth of the solid equal to 40 millimeter. And these two horizontal projector lines, we have appropriately extended them onto the transfer line such that we can transfer this depth of the solid equal to 40 millimeter into the left hand side view projection view over here. So here we can check into the left hand side view projections, we have been able to obtain the left hand side view face of the solid measuring 40 millimeter depth of the solid and 25 millimeter height of the solid. Now let us proceed to evaluate different constructional details of this engineering object. Now we can divide the solid into three elements. Element number 1 happens to be a horizontal wave which is having height is equal to 5 millimeter, which is lying at the base of the solid. Above this horizontal web, here we have got an L-shaped web which is resting towards the right hand side face of the solid over here. Now here we have got an element number 3 which is a square prism having base equal to 15 millimeter and height is equal to 20 millimeter, and the square prism, it is resting towards the right hand side face of this particular solid at the rear end of the solid over here. Let us now evaluate different dimensions alongside the width of this particular solid. So we know that this element number 2, which is lying on top of the element number 1, which is a L-shaped web over here, it is having cross section which is measuring width is equal to 15 millimeter measured from the right hand side face of the solid. So from the right hand side face of the solid, now we have measured a distance of 15 millimeter and we have obtained a vertical projector line into the front view projections, and this vertical projector line has been appropriately extended into the top view projections as well. Similarly, we have got this face of element number 2. So this face of element number 2 and this face of element number 1, they have both coincided with each other. And how much is the distance? This distance is 10 millimeter from the left hand side face of the solid over here. So now from the left hand side face of the solid, we have measured a distance of 10 millimeter corresponding to this distance. So this distance will apply to this rectangular portion as well as this rectangular portion over here. So now having measured this distance of 10 millimeter from the left hand side face of the solid, so once again we have obtained a vertical projector line into the front view projections, and we have extended this vertical projector line into the top view projections as well. Now we have got this horizontal web or the element number 1. So we know that the height of this horizontal web, it is equal to 5 millimeter. So this total height was provided to us as 15 millimeter, while the height of element number 2 happens to be 10 millimeter. So this remainder height will be 5 millimeter. So now we have marked a distance of 5 millimeter from the XY reference line or the ground, and we have now obtained a horizontal projector line into the front view projections, and we have appropriately extended this horizontal projector line into the left hand side view projections over here. Now we also know that corresponding to this surface, top surface of element number 2, which is a L-shaped web, it is having height is equal to 15 millimeter. So now we have measured the distance of 15 millimeter from the base or the ground, and once again we have obtained a horizontal projector line into the front view projections, and we have extended this horizontal projector line into the left hand side view projections over here. Now we are going to darken different faces which will be visible to the observer, as the observer is going to look at the solid from the front view orientation. Now as the observer is going to look at the solid from the front view orientation, so this rectangular portion or this rectangular segment of element number 1, this will be visible to the observer, and since this rectangular cross section happens to be parallel to the vertical plane, so we are going to obtain the true shape projection of this rectangular cross section of element number 1 onto the vertical plane into the front view projections over here. Similarly, when the observer will be looking at the solid from the front view orientation, then this L-shaped surface, which will include element number 1 and element number 2 over here. Again, this L-shaped surface, it is parallel to the vertical plane, so its projection onto the vertical plane into the front view projections will provide us true shape projections of this surface in the front view projections over here. So now we will see that corresponding to element number 2, this is the rectangular surface which is once again parallel to the vertical plane. So this element number 2 vertical surface, it will be projected as true shape projection into the front view projections over here. Finally, we have got element number 3. So we can check certain portion of element number 3. It has already been covered by this surface of element number 2. But this portion of element number 3, it will be visible to the observer, as the observer is going to look at the solid from the front side. So we are going to obtain the true shape projections of this element number 3 visible portion, or the total portion of element number 3. So this will be the total portion of element number 3. So this total portion, it will be visible to the observer as true shape over here. And now we can check another thing. This element number 3, it is resting on top of element number 1. So the base of this square prism, it will not be visible to the observer from this orientation. So we are going to obtain a hidden line projection into the front view projections corresponding to the square prism which is lying on top of element number 1 over here. So we are going to obtain a hidden line projection corresponding to the base of the square prism into the front view projections over here. This way we have been able to obtain the front view orthographic projections of the solid. Now let us proceed to evaluate the top view orthographic projections of the solid. Now as we look at the solid from the top, so we observe that corresponding to the square prism, that is the element number 3, which is lying onto the rear side of the solid over here. So here we have got the depth of this element number 3 equal to 15 millimeter. So now we are going to mark a distance of 15 millimeter from the rear face of the solid. So this distance happens to be 15 millimeter, and we have obtained a horizontal projector line into the top view orthographic projection area, and we have transferred this distance of 15 millimeter using this transfer line onto the left hand side view projection area over here. Next, we know that corresponding to element number 2 and element number 1, so this distance happens to be equal to 30 millimeter. So this surface and this surface, they are going to lie alongside the same horizontal line, which is available at a distance of 30 millimeter from the rear face of the solid. So now we are going to mark a distance of 30 millimeter from the rear face of the solid. So this is the rear face of the solid. Having marked this distance of 30 millimeter from the rear face of the solid, again we have obtained a horizontal projector line into the top view projections, and we have transferred this horizontal projector line using this transfer line into the left hand side view projections over here. Now let us obtain different faces which will be visible to the observer, as the observer is going to look at the solid from the top. Now we can see, as the observer is going to look at the solid from the top, so this square portion corresponding to the top surface of the square prism lying onto the rear side of the solid will be visible to the observer as a true shape, because this surface happens to be parallel to the horizontal plane. So we are going to obtain true shape projections corresponding to the square top face of the square prism lying onto the rear side of the solid. Next, corresponding to this element number 2. So here we have got the L-shaped surface visible to the observer from the top view orientation over here. And once again, because this L-shaped top surface of element number 2, it is parallel to the horizontal plane, so we are going to witness true shape projections corresponding to this L-shaped surface of element number 2. Next, we have got this rectangular surface corresponding to element number 1 or the horizontal web lying onto the base of the solid. So since once again this rectangular surface of element number 1 or the horizontal web, it is parallel to the horizontal plane, we are going to witness true shape projections being obtained onto the horizontal plane in the top view projections over here. And finally we have got element number 1 L-shaped surface available over here. So again this L-shaped web will be visible to the observer as a true shape projection into the top view projections, because this surface is once again parallel to the horizontal plane. So this way we have been able to obtain the top view projections of the solid onto the horizontal plane over here. Now let us obtain the left hand side view projections of the solid. Now when the observer is going to look at the solid from the left hand side orientation, so this rectangular face which is corresponding to element number 1, it will be visible to the observer as a true shape rectangular projections, because this rectangular face will be parallel to the profile plane. Similarly, this rectangular face which is corresponding to element number 1 or the horizontal wave, it is again parallel to the profile plane. So this rectangular surface will also be visible to the observer into the profile plane as a true shape projection. So this projection is also true shape, this projection is also true shape. Next we have got this square shape projection over here. This is measuring 10 millimeter by 10 millimeter. So this square shape projection corresponding to the square surface which is corresponding to element number 2. So here this surface is again parallel to the profile plane. So we are going to witness true shape projections of this surface into the profile plane in the left hand side view projections over here, then we are going to witness this rectangular face over here. So this rectangular face corresponding to element number 2, once again it is parallel to the profile plane. So this rectangular surface projections onto the profile plane will reveal the true shape projections of this rectangular surface of element number 2. Now finally we have got element number 3 over here, which is a square prism. So this is the rectangular face of the square prism, which will be visible to the observer as a true shape into the left hand side view projections over here onto the profile plane. So here we are going to obtain the true shape rectangular projections available onto the rear side of the solid over here in the left hand side view projection view over here. So this way we have been able to obtain the front view orthographic projections of the solid, the top view orthographic projections of the solid, and the left hand side view orthographic projections of the solid when the 3D isometric projection of the solid it was available with us to begin with. So this is all for today. So I hope that through this discussion you would have understood about the procedure to evaluate front view, top view and the left hand side view orthographic projections when the 3D isometric projections of the solid depicting the constructional details of the solid was available with us. So we are going to continue with further discussion regarding few more illustrative cases of orthographic projections of the solids in the coming lectures. So thank you very much. Thanks a lot.